My name is Paul Seeberger, and I teach math at Monroe Community College in Rochester, New York. I've been here since 1998 and been working with the LibreText platform since 2018. So I guess let me actually open or share my screen here and get my PowerPoint slides going. If I can find the right page. It always changes when I come out. There we go. All right, so the title of my talk, as you already know, is about using LibreText in math courses like calculus and differential equations. I am going to focus first on differential equations, but then I will show you how I've used it for calculus and really Calc 1 through 3, and just talk about some of the different things you can do with it in any course on the LibreText platform. So I guess I'm trying to get my cursor to work here, but somehow it's not letting me locate one thing I'm trying to do here, but oh well, I think I'm good. So this is just an image of the Monroe Community College LibreText page, which I think has one or two more things at the top on it now, but it basically shows the courses that we have currently and some variety, I guess. Even for Calc 1, we have two different versions, custom versions of Calc 1, the textbook that we use. And at the top, there's a couple of training materials, modules that you can access if you're interested. But I'm going to, again, start at the bottom with a Math 225 differential equations course and show how I've adapted the Trench textbook for use in my differential equations class. Going back to when I first started teaching differential equations online, I began teaching it with OER textbooks. One of them was a PDF of the Trench textbook. And there were a couple of things in that book that I always wanted to change. It has a lot of coverage. It's not perfect, but it really helped me to do the job, along with a couple of other online textbooks, which I still refer the students to in a couple of areas. Paul's Online Notes and Label Differential Equations, which actually is also now on the LibreText platform, if desired to customize. But I've been able to customize the Trench textbook now on the LibreText platform. I'm going to show you a little bit about how I did that. Since 2015, when I began to use LibreText in 2018, I began to bring over my other courses to OER textbooks. And I've taken basically OpenStax Calculus books, Calc 1, 2, or 3, and I've brought them over and customized them on this platform and been able to really improve them for my use. And I'll show you some of the ways that I've been able to do that. Some of it has been clarifying or adding examples. Other places it's being able to put in dynamic figures that are rotatable. And again, I'll show you some of that as we go. To get started, I wanted to again consider some of the things that LibreText platform has been really helpful for. It's really very nice for customizing content. So being able to pick and choose from available OER textbook content that's out there and be able to create something of your own that you can add your own content to really easily and put it up there and have your students use. It makes everything look coherent, as I'll show you. You can renumber chapters and it looks right. It looks like it belongs in the order that you have it. And you can do a lot of other things that just makes it look good. You can adjust wording, which is an easy first step in customizing a book. You can add solutions, missing steps, add new figures or replace figures that aren't quite right. You can add new subsections, which I've done, and I'll show you in a minute, or add new sections completely, which I'll show you also. And then the fun part is being able to add or use at least the interactive content that's there. So let me move on to the next page where I'm going to show you some of the things that I've done with my OER Trench book. So this is the part where I really was most dissatisfied with the book in the PDF format. In chapter 8, where it talks about Laplace transforms, Trench chose to evaluate limits at infinity. As you can see on the left side, you can see in the middle there, somehow my cursor is not showing up for me anyway on my PowerPoint, but you can see in the middle there that the improper integrals, instead of having a limit have just evaluated like a fundamental theorem of calculus directly at infinity. And this is something I don't want my students to do. And so I didn't think it was helpful to have that in the textbook. And I was able to rewrite this material as I showed you the beginning part of on the right. I'll show you in the book itself a little bit here in a couple of minutes. But in addition to taking a shortcut for evaluation of these improper integrals at infinity, Trench also chose not to show the integration by parts step. And so I was able to expand the problem, as you can see on the right, to include the integration by parts step as well. So really a lot of stuff out of that very beginning part of the problem, I expanded for the first part on the right. And on the next page, there's more. So if we come down to the next slide here, it's just more on the actual page when I'll show you in LibreTexts. You can see more of what I have included, also arrows going to infinity over infinity and to 0. And you can see the infinity over infinity one. Really, I would require my students to show L'Hopital's rule for that step. And so I also show that step in the problem, where the original, he skipped all of that, and I guess assumed the students could read between the lines and understand. And perhaps that's, you know, what some of you might think too, but I wanted to make it more clear and make it more like what I want my students to, how I would want them to write the problem out. So let's see, with that, I think, oh, this is something else I'll show you in a minute. This is the GeoGebra applet that I've created for Spring Motion, and I've embedded it in the Trench book in the LibreText platform, and I'll show you that here in a moment. I think that is where I wanted to jump to it. Let me go ahead and come out of this and get to the LibreText itself. Let me see if we go the right direction. Here we are. So this is, first of all, the page that is the Monroe Community College campus bookshelf. If you choose to customize a book yourself, you could have a book placed on your own campus bookshelf and easily accessible for your students and underneath your college name. You can even have a college logo on the previous page, as you'd see if you go back one step. This page for me shows a little bit more than you would see since I'm logged in as a user or as a professor. So I have a learning objects page, which I think is hidden for those who aren't logged in. And same for this component over here. It's just a part that's being worked on. But below that, you can see the other courses that are here. And I've created some of the images, like for the Calc 2, the volume of revolution image and the Calc 3 image. You can add your own images to the fronts of these books. My colleague, Mary Cameron, created this book for 165 and 175, our college algebra and pre-calculus combined. So what I want to do now is look at this look at this differential equations book and show you what I've done with it. So let's start in 8.1, since that's what I was talking about. At the very top of the page, if I jump back up here, I guess just to show what it looks like, there's a table of contents for the page, which includes the examples and subsections. It's a little busy on this page. There's a lot of examples, so I'm going to close it back up. You can go navigate through a book in the LibreText platform using this contents on the side and choosing a chapter and section. Usually within the sections, there's an exercise set that you can also navigate to. But we're going to start right here in 8.1, and I'm going to show you how I've adapted it a little bit. So coming down, I changed the notation for the Laplace transform to a script L. This is the one that I guess I used first when I taught the course in another text, and I liked it better than the notation that had been used in the Trench book. So it's up to you, I guess, how you choose to customize it, but that was my editorial choice I was able to make. I just went through the chapter and did a replace in the text when I edited the page, as I'll show you how to do in a moment. So I think the first example was fine. He used a limit appropriately. And so it was on the second example where there was a difference. So this is my version of it. It greatly expanded from what I showed in my slide. Has the integration by parts step, and the next couple steps here and then the L'Hopital's rule as well. So trying to explain each of the steps clearly so that we can get to the result at the end of this process. And I had to change most of this in the first section. There were a few places later on in the chapter that I also had to make changes in addition to the notation for the Laplace transform, needing to evaluate improper integrals with limits appropriately and adding in the work. So I was able to do that pretty quickly. Here's another example on this page where you can see I've got the arrows going through, going to 0, having that part going to 0 and so forth. And I'm able to put in the explanations. Let me show you how I edit this page, and that might be a good introduction to what it looks like to edit one of these pages. So as you're logged in as a professor, having the book, having an account on the LibreText platform, you will be able to edit your work. So initially it would be books that you've remixed into your sandbox. And then once you've had that book or got it ready, which might be right away, once it's on your campus bookshelf, then you'll still have access to edit those books in this way. So you can see in the edit mode, the text is all just normal text, which we could edit and change. I could add something to the beginning of it, say, this is Paul Seeberger's version of this section. I probably won't leave that in there, but that's something I could put in. You can see the math. This is indicated with MathJax, which is basically LaTeX. Most of LaTeX can be implemented here with inline math between these backslash parentheses, open and close, and then display math between these backslash square brackets. Now, display math will typically be centered, and integrals will look all a little bit nicer the way they should. There are ways of making display math, display style to do integrals or represent integrals correctly in line as well, as I'll show you further down. But it also generally gives it a number, unless we decide not to have it have a number, in which we could control with a no number command, as you can see on these. Actually, no number will remove the automatic numbering that is given to those equations or those math lines. So further down, I think I edited actually example 2. So you can see here that it's pretty intense if you haven't done LaTeX editing. If you have, then this will be something familiar to you. So this is an align, which means it's going to align the equal signs typically. We've got an and or an ampersand before the equal signs, which lines them up. And then we have an end align at the end of the alignment block. So a little bit technical looking when you first learn this. You can actually use something like MathPix, which I sometimes use to convert an image of an equation or a mathematical expression into LaTeX like this. So there are ways of shortcutting the process if this is an unfamiliar notation for you. But it's actually the same notation as is used in, say, the Lumen platform, or if you've edited problems in WebWork, again, it's the same notation, the LaTeX that's here. So that's probably enough to show you how this works. Let me go ahead and delete this part. Actually, I'm just going to add something else just so I can show you how it works, and I can come back and change this. My students aren't on this yet anyways. So let's say we want to put some inline math in here just for an example. So we got f of x, maybe I'll put a space after that just to show that's the beginning. And then we'll put equals, and we'll put a fraction. There's a top part and a bottom part. So I'm going to make this a display fraction, which would be like it were a display mathematics, but since I've got inline right here indicated with the open or the backslash parentheses, I'm going to just force it to be a display fraction. And then down here, I'm going to put a square root, and then braces are used to indicate what's inside. Put x squared plus 9, and maybe I'll put something like in front of it to show it's display mathematics. This is my favorite function. Not really, but hey. And then let's see a display mathematics example. Just to show how this would work, I could put something like f of x equals x cubed minus actually backslash sign of x. And so then saving this page, we'll see what it looks like. And at the top of the page, we should have what we've edited. So we've got the, oh, I made a mistake by not including the end of my line there. I need the backslash and closing parenthesis. But you've got your inline mathematics or your display mathematics, excuse me, just below that with a number on it now, making it the first on the page. And I'm going to go in and show you how it would have looked if I put the correct ending on this line. So you need a backslash and close it. And this one also needs to be a backslash. Put the wrong slash there. Save that. And now, there we go. This is my favorite function, f of x equals 1 over square root of x squared plus 9. So that's how this will work. I'll come back later and edit this page to fix that. Let me show you next the section that I added this semester. So I was always wanting more content on bifurcations. The books I've used have had a little bit in them or none. So the OER books like Trenched had nothing on bifurcations. So I wanted to add some content. So I've gotten a good start on it. I'd like to do more, but this section gives an introduction to what bifurcations are, dealing with basically changes in the nature of the solutions that occur as a parameter is adjusted in the differential equation. And so I describe that initially, and then I go through one example completely, talking about it, going through a trial and error approach. This is all content I've added to the book myself. It looks like it belongs here, same numbering system, same look to the mathematics, and so on. I got images, some of which I hand drew and then took photos of with my phone and was able to import into the page, make it a figure number, and add alt text and so forth. Down below, let's see, I've got a couple of other ways of representing this once I get past that initial trial and error approach. So looking for a better way to identify bifurcations, doing it algebraically and graphically. So sort of doing the general approach that we'd all probably hope our students would be able to show, going through using the A in there. And in this case, when you solve, you basically are solving for zeros of the differential equation, looking for equilibrium solutions. And you want to see when the number of equilibrium solutions would change from maybe 0 to 1 to 2. And that's indeed what happens at A equals 1 here. So we go on down below here, and I was able to add a GeoGebra applet that I created right into the page. So this is a graphical approach. So as we vary the A value in our differential equation, it turns out we're able to then see how we have no equilibrium solutions on the right there as A is bigger than 1. At A equals 1, we have 1, and you can see a phase line on the right. If you're familiar with the differential equations course, that might be a familiar item. And then as we move to the left, we can see we have 2 of them, and they show up over here as well. So we have that change from 0 to 1 to 2 that occurs when that parabola, in this case, the curve is a parabola. It could be another type of curve, but when it touches the axis here, when it's actually tangent to the axis. So this is just a quick little lesson in bifurcations, I guess, but showing you how that gives us really a lot of visual information using this applet in the page. So further down, I talked about how they won't always have an applet for the problems they're looking at, but they may be able to use something like Desmos to identify the bifurcations graphically. And so I showed how they could do that by inserting or embedding a Desmos graph that you can vary and see when it's tangent to the x-axis. Really, you had to do it in terms of x here, just because that's how Desmos starts out and works most easily. So helping them to vary that and play with it. And then there's an exercise where they get to do the same thing for a new one. So trying to see where we'd end up with a change, a tangent like we have here at A equal -2. And then it happens again over here, actually, at A equals +2. So being able to vary these things and explore and sort of learn by doing. There is an answer that pops open when you click on it, as happens in a lot of online textbooks. So that's useful. You can close it back up if you wish. Okay, then I talked about drawing bifurcation diagrams. So using the same example, went through, drew these by hand, included the images, and then included another GeoGebra applet, which is actually now not just the graph of f of y or dy dt, but actually looking at the bifurcation diagram and seeing how as we change the value of a, it changes where we are in that bifurcation diagram, and it changes the equilibrium solutions on the right and shows what the solution curves would look like, showing that we get an unstable equilibrium here at the top equilibrium solution and a stable one at the lower one. Okay, and indicating some of that information with open circles and closed circles and dashed lines and so forth. So if you're familiar with that, maybe that looks familiar to you. I added steps to create a bifurcation diagram. I made these up. I hope they seem accurate. Feel free to give me any feedback on this section, by the way, if you happen to have some suggestions for improving it or making it more accurate. So the last thing I did was give the students a chance to try one of their own. And in this case, I basically included a whole nother example in the answer. So if they work it through first, as they should ideally do, then they get to see all of the work for how it works out that I put in to the answer. Okay, no GeoGebra applet this time yet, but that's what I put in here. So again, I created this one from scratch and was able to do that pretty easily here in the LibreText platform. If I go back to the top of the page, I could show you how I edited this. Again, not changing too much here, but most of it is just easy stuff to enter. The parts that might be more interesting are the figures. Okay, and to get the figures first, I ended up going up to this elements area, come down to templates, and under templates, I was able to pick add a figure, center, center. You can also add a figure multiple, so like two next to each other, center, center, and that's something else that you might look into, but this is what I use most often. And when I insert that template, it starts out with a placeholder caption and a placeholder image. For the placeholder image, I usually actually, rather than following the instructions, I just right-click on it, click on the image properties, and then I come out to usually attach files, unless I've already attached them. And we can either pick one of the existing files that we've got on the page, or we'd choose one from our computer, and that's where we would insert it. Then we'd need to change the options, including, oh, this one looks like it needs the alt text to be improved, although this was, yeah, well, it needs to be improved because it's the default placeholder. I thought maybe this was one of mine. But this is where you'd put your alt text, a short description of the image to help your page be compliant for people reading it with a page reader. You can change your size of your image. Sometimes I use medium just to get it to a normal manageable size and so forth. So I'm going to cancel this for now, and I'm not going to actually add this. I'll cancel here at the end of it, but I just wanted to show you how to do that. So there's lots of other things here. I guess adding a GeoGebra applet is done in a little different way. I use the content reuse item and put it into a figure in this case, but the content reuse is a way of pulling a page of content from somewhere else on LibreText into a page that you're working with and customizing. And I could show you how to do that if we have time, maybe at the end, but I want to be sure I've got time to do everything else first. So I'm going to cancel this edit, and I want to discard the changes. And now I'm ready to look at another section in this differential equations book. I've already got it open, so I won't use the navigation at the top. This is for the spring section, so spring motion. And I've got both forced and unforced motion illustrated on this page, but this is the more interesting one. So I wanted to show this one. So I've got forced motion, which I've been able to create a GeoGebra applet that illustrates it. If we click on the play button, it will implement the current settings with the various values for mass, 0 for our damping constant, and then a spring constant of 1.5. It turns out that this one has beats evident, and you can see how that looks. What I really wanted was a demo that showed how the forcing function could work. And this gives us a true representation of a cosine-based forcing function. So you've got this bar going around that pulls that spring up and down, sometimes pushing with it, sometimes pulling against it. And you can see how it behaves here, reacting to that forcing function. All right, so anyway, something interesting. If you're interested in using this, even as a supplement without customizing a full book for your course, feel free. That's a great use of the content here, the resources here on the pages of the LibreText platform. Let's see, the next thing I'm going to show is in a different course. So this was what I've done so far for the differential equations course. Wanted to show a little bit of what I've done in other courses. So the calculus courses, again, I've taken the OpenStax books that are on this platform, and I've been able to customize them. And Calc 1, one of the sections that I've customized most is actually the limit laws, where they didn't have a lot of examples of trig limits, which is something I want students to be familiar with. So they covered the squeeze theorem, and they did a good job there. But then they had an exercise, but they didn't give very much of an answer. I think like this exercise down here, this one might have been in the book already, but it didn't have a section title, which I added. So here, this one is here, but the answer was just given a 0, I think, which I thought was more interesting or more useful to give them all the work I'd want them to show if they were to do this problem. So that's what I put in here. I also added my own example. So with 3 parts, three different really sub-examples here of the limits done with a trig in them. So where you end up using the limit of sine of theta over theta as theta goes to 0 equals 1 to end up working it through and solving for your limits. So again, just an example of how I was able to use LibreText, the platform, to customize a book, add explanations for the various steps, and so forth. And I'd be glad to help you to learn how to do this if it either looks familiar or unfamiliar to do this kind of formatting. But sort of a great opportunity to be able to adjust things in a book that you're not quite happy with, or you're happy with mostly, but not happy with all of. Okay, in Calc 2, the biggest change I've made to this book is adding in volumes of revolution graphs. So there were problems that were already there, but in fact, they even had their own images or figures, but they were static. And using Matplotlib 3D, which is another project I've worked on, you can insert dynamic figures into a page. And this is an example of one. You can take this region and rotate it about the axis that you're given. In this case, I made it possible to change that axis to another vertical or horizontal axis. So we could change it to say something like y equals -1, and that shrinks it down a little bit. Could make it y equals 5. That puts it up above. Could even make it x equals something. And let's say x equals 5 would be reasonable. So you can see how that would look. And this is something you can do in Matplotlib 3D, but this is a more limited, focused example that's able to go along with the examples in the book. Now, this one actually used the shell method, even though we're actually still at the end of the washer method section. Let me show you what these would look like. So we're able to choose to show n washers or shells, and we can see if we unrotate this, what those look like. If I went back to where it was originally, y equals -2, you can see these are the washers that were being talked about in this problem. And we can increase the number. It actually shows us the volume that comes out of the full washer method and lets us compare it with what the decimal form of the exact answer would be as well. So something that you can play with if you find this helpful. There are 3 more of these on this page, and then you can, of course, use Matplotlib 3D to generate more if you'd like. Okay, in Calculus 3, I did a lot of work, and this is the first book that I customized on LibreText platform. One thing that you can see on this page is that I was able to make the vector format more in line with what I want my students to write on paper. I've always felt that just having bold letters in a textbook or italic letters wasn't really quite enough, because then students don't really learn. They don't see it, and it's not reinforced that they really need to show that when they write it, that it's the vector by putting some kind of an arrow or harpoon over the letter. And so I've bolded the letters and also put harpoons over them in this textbook in my custom version. And in fact, I, as an editor and curator of the math library for the LibreText platform, I've been able to choose to make that a notation in the source book for OpenStax Calc 3 on this platform as well. So something that I chose to do, and I think it's worthwhile. But what I wanted to show you on this page actually was how some of the figures, which are three-dimensional, can be made rotatable, like we saw in the Calc 2 volume of revolution example. This is basically the figure that was in the book. And you can sort of see that the line, the three-dimensional line, is three-dimensional and parallel to this vector, the direction vector of the line. But being able to rotate it like this makes it a lot easier to see that they're parallel and that line is really three-dimensional. So this is one of my favorite examples of making a figure dynamic and rotatable. Further down on this page, there are several actually examples, but the other one I wanted to show you is the first one that I was able to create a three-dimensional rotatable figure for, and that's this one, the intersection of two planes. So in the original version of this from OpenStax, there was a little bit of a mistake in that the planes were really just transparent, and they weren't, there was really one in front of the other in terms of what you could see. So you couldn't really see the intersection clearly. And so I wanted to do this one over first, and I was able to make it rotatable as well. So that was an added bonus to create this three-dimensional rotatable figure for this textbook. So just an added bonus from using this platform is that we can put these dynamic figures into the pages if we desire, and some of them already have them. Like this one is actually embedded in the source textbook for the OpenStax Calc 3. Okay, in fact, any of the mainstream figures that I've taken and just converted to three-dimensional rotatable versions, I put into the source book. By the way, if you find any typos, either in my version of the text or in the OpenStax versions of the Calc books or the Trench book, please let me know and I can fix those. You may find typos certainly in other books as well, and let me know and I could address those typos as well. Let's see. The other thing I wanted to show here is, well, I did make a lot of changes in 12.1 that made the problems a lot easier. I'll just quickly show these. But basically adding components for how to trace out a vector valued function along a graph of a function, y equals f of x, either from left to right or right to left. More interestingly, further down, this is all my added components or added subsections. This was a problem type that students had trouble with, parameterizing a piecewise path. So I added my own example, used an image from CalcPlot 3D that's static, it's two-dimensional there, and was able to show how we could do that in a systematic way. And since I added this particular example, my students have asked a lot less questions on this particular component. So that's been a real bonus from this, being able to edit the book and add new content. Section 13.7 in my book is a section I wrote. It's about Taylor polynomials of functions of two variables. It has components, or all basically my notes and my examples in it, including some 3D rotatable graphs. And at the end of it, at the end of this page, I was able to add some content, which I developed, basically something I couldn't find out there, probably out there somewhere, but I couldn't really find it. And I was able to basically generate a way to represent an nth degree Taylor polynomial of a function of two variables in a way that's actually able to be programmed and or be used by a student to generate higher order Taylor polynomials of a function of two variables. So I go through a third degree in this example, and then I have them look at maybe another third degree or fourth degree in a practice problem that I created. Anyway, something that I thought was fun. Now, and what I want to also show is in my chapter 15.5, so curl and divergence, near the end of this section at the bottom of the page, I added a check your understanding component, and it's where I've begun to add some formative exercises using web work. These you can enter your answers and check to see if they're right. You could show the correct answers as well if you're not patient enough to try or can't find the right answers. A couple different ways these have been displayed. This one's coming from my web page so that I can, or from my WebWorks server, so I can use custom problems. And these that below are from the library on the LibreText site. So they are WebWorks problems. This one's a H5P problem, which you can actually, give it a try. I don't know what the answers are here. I didn't think about it, but check and it gives you feedback, whether you're right or wrong. Sort of cool, great formative stuff. These are some graphs you can pick, positive, -0, or divergence, I think in this case. And so these are just some problem types that you can put in. WebWork, H5P, MyOpenMath problems can all be added into web pages here. You can actually also have them be assignable. So something I haven't chosen to do yet is to have problems in the pages be assigned, have my homework problems in there, but you could choose to do that. All right. The remixer is the way that you would generate these books first. It allows you to, I guess if you're logged in on one of these pages, you'd get to it by going to the tools. And then on that tools page, you'd find the OER remixer. It takes a moment to open. So I'll just jump over to the page here that's already open. I need to go back actually to the previous page here because I already had used this one practicing. Maybe I'll open it again. Click on it and see if it takes less time this time. Sometimes it takes a minute to open. But anyway, this allows us to pick a book from either the campus bookshelves where my books are, or from the main bookshelves where the source books are, and to create your own version of the book and put it on your campus bookshelf eventually so that you can share it with your students. And again, if this is something you're interested in, I'll be glad to help. Again, this is taking longer than I like to open this page, but this is how it looks when it finally comes up. So the remixed name would be your book name. So you could say something like Calculus 1, Test 2. I don't know if I have a Test 1 out there already. Enable auto number is usually on. For me, I typically have it off, but depends on whether you want it to start at chapter 1 or not. We could delete the default chapters unless you'd like to populate them with sections. I usually put the information here in a section at a time. So if we go to bookshelves, go down to calculus, and then maybe pick the OpenStax Calculus, which is here. And then say we want to pick for Calc 1 functions and graphs. We could actually pick the whole chapter and bring it over. And just be sure that our arrow comes down in between. Oops, there we go, the front matter and the back matter. And then if we wanted the limits chapter, we could bring it over. If I put it before the function and graphs chapter, it will renumber them. Eventually, there we go, limits 1, functions and graphs 2. I don't really want that order. So I'm going to grab that and put it down below, get it in the right order. And once you're ready, you have all the chapters and you want, you'll go ahead and save to server. It tells you what it's going to do. It copies most of the pages in a form that's called copy transcluded. Essentially, that just means they're linked to the source. So if typos are fixed in the source, they'll be fixed in your version. You will have your own chapter numbers, though, that will update and be accurate according to where the sections lie in your book, the way you've laid it out. There will be a few pages that will be forked. Those will be the ones that are the chapter headings. So that doesn't show up here, but you'll see that when I save to server here. And this may take a second, although I only did 2 chapters. But once it comes up with the first couple of pages here, I'll show you what I mean. So it says forked, number 1, functions and graphs. That really is just, again, the chapter holder page, which lets you adjust what's on that one page that holds chapter section 1 and section 2 and so forth without adjusting or changing or affecting the original book. All right, with that, I think I'm going to go back to my PowerPoint slides and finish off this presentation there and see what questions you might have. So let's see, if I come back here, just wanted to mention that LibreText is supported by many different grants. grants from the NSF, grants from the Department of Education. Currently, there's a big grant from the department, or from, I think, California Department of Education. I don't have the details on this page, but Merlot and many other sources are supporting the LibreText project. LibreText books can be downloaded as PDFs, and your students could order them or have them printed and pay a small price depending on how many pages are in it. It gets a little bit more expensive when there's more pages, but be able to access it that way. So a lot of my students use it just online. I've had a few that have downloaded the PDF. I don't think I've had any that have purchased a printed copy, but you could do that. Something else I didn't mention earlier is there is an annotation, free annotation service that you can use on LibreText that really is a wonderful a tool that some of my students have used to keep their own notes in the book. Anyway, the physical textbook, this is what it looks like. Prints out really nicely. The one thing that, of course, you're not going to have are the dynamic figures. So any of the dynamic material or interactive material is not going to be present in a printed book. I already talked a little bit about these things. Those, by the way, were pages from the printed book. But some of the things I love about the LibreText platform is that I can customize the textbook to present the material in the way that is, in any way that is consistent with my approach. And I can clarify things, I can add examples, and help make it a better tool and resource for my students. The students have the book right away before the course begins, and they don't sell it back. Generally, that's true of any OER book, but I really like that aspect. I can adjust the wording, like I said just a minute ago, I guess, to add new examples on the fly when students ask questions on a topic that I see they really need some more help on. I offer students bonus points for finding typos or for suggesting places where the wording is unclear and can be improved. And this has actually greatly increased the number of students who tell me, at least, that they're reading the book carefully. And I've gotten a lot of students who have found things that I've been able to fix. And once they're fixed, they're good for everybody, everywhere the books are used. So often it's a typo in the OpenStax book that I can fix. Sometimes I can able also to report it to them if it's still a problem in their book. As I go through these books, in terms of customizing them for my courses, I usually first look through a book when I'm first starting to use it for typos that might be in the source, and I'm able to fix those in the source myself. If you find them, you can let me know, and I could fix them in the source once you basically have begun to show me that you're able to edit these textbooks easily and you know the LaTeX. If that's the case for you, we may be able to set you up and be able to help me edit the source books as well. But once I do that, if I find a page that I want to actually customize and not just fix a typo in the original source book, then I would fork that section and be able to adjust the wording and add my own content to it. I'm going to skip this page, I think, and this one too, basically talking about that already. Talked about the remixer already, showed you how it worked. And basically the power of the LibreText platform is it really is designed to integrate existing OER textbooks. If you don't find an OER textbook that you like or have used on the platform and it has licenses that are open to being able to be used by others and remixed, then we can get it imported into our library, and you could begin to customize it more easily on our platform. It allows you to edit and typeset to a central standard. We do try to do certain things in a way that's going to look consistent so that the books can be remixed and mixed together. There's ability to cross-reference and add meta tags for content creations. The OER remixer enables you to rapidly construct a customizable textbook. There is a way, if you want to edit material, I guess, add your own CalcPlot 3D dynamic figures. There's a manual that would help you to do that. I'd also be glad to give you a quick tutorial on that at another time. Okay, thank you for attending. If you have questions, you feel free to stick around. I've got, I guess, a QR code on here if you wanted to jump right to the differential equations text. If you didn't already get that information, you can also search for it on Google. And my email is here if you're interested in editing textbook or customizing one for a class, feel free to email me and I'll be glad to help you get set up. So with that, what questions do you have?
Hey, Paul. Thank you,
Yeah.
by the way. Anton's asking about replacing the interactive content in the print files. Now, I know we can use QR codes for that. Are you aware of how that exactly works?
I think we've been talking about different ways of doing it, and it might still be sort of being in development in terms of what we've chosen, but I don't know right now what the current choice has been. We've talked about having a static image, but also a suggestion had been made before that we could add QR codes, like you said, Stepan, to bring that content up. So that's a good suggestion, and hopefully we can. I'm sure we can implement that. I see there's a lot of comments here in the chat.
I answered the ones that I could, but if anyone has specific questions for Paul, please do chime in.
I'm trying to look through them, but if anybody wants to speak up, feel free.
Yes, you should all be able to unmute yourselves if you'd like to ask in person rather than typing it into the chat.
So I have a question.
Sure.
What would be the best way to get started on this? I have a little bit of experience typesetting in LaTeX, and I'm interested in calculus. So what would be a way to get my I guess, jump into the pond and get started?
Well, I guess signing up for an account on the LibreText platform in the Math LibreText library. You can email me if you don't see how to do that right away, but that'll be the first step. And then, there are a number of other tutorials and YouTube videos out there that may give you some added help, but I'd be glad to give you some initial tutorial, help in getting you started if that's something you'd like to do and you could find beneficial. So it's a pretty easy start if you're familiar with the LaTeX. Especially if you're not familiar with LaTeX, it's still not too hard to get started. So it's just a matter of getting a book set up, a remix book, and being able to begin to play with it.
Right. Thanks.
Yeah, you're welcome. Any other questions or comments or suggestions? I tried to make this, by the way, shorter than the full hour so that you'd have some time to ask questions if you wished. So.
I did put the link for accounts in the chat.
Thank you.
Everyone, feel free to use that. Accounts are free. Single sign-on is coming. Right now, you do have to create an account for each library that you want to have editing rights to. Each account comes with a sandbox, your own private sandbox, which is where you can go in and play with as much content as you'd like without breaking things.
Yeah, so there's a library for mathematics, a library for statistics. Those are similar, but different enough that they're in different libraries. There's chemistry library and physics library and so forth. So there are different libraries for different STEM areas. So again, any other questions that you have?
All right.
Appreciate your positive comments in the comment section and interaction there. Thank you all for coming.
Yes, and please, everyone, do take advantage of Paul's offer to help get you started. He's one of our amazing super users and is really an invaluable resource. So I encourage all of you to reach out to him and to us at LibreText as well if you have additional questions.
Thank you so much. Thank you.
You're welcome.
Very much. Okay.
You're welcome, Chow. Thank you.
Thanks for coming, everyone. I am going to stop the recording. It will be available on YouTube probably a few weeks after the conclusion of Open Ed Week.